good morning, everyone. How did the homework go? Any questions? I know some of you did not do it. Please do not wait till Friday at the last minute to do the homework. It doesn't really help you much. Try to do them every day, okay? I mean, I looked you over you. Some of you haven't even touched the homework. This is not the way to succeed in the course. You have to do them daily to be able to do well in the course. It's not an easy course. There will be new material every day. So please do them daily. And if you have questions, I answer them, but you have to try to do them. I know who's doing them and I know who's not really touching the homework yet. So please do not fall behind. All right. So okay, number 10, 49, almost all of them. Okay, so we start looking at them one by one. So let's look at number 10. Oops. Okay. And we have here the graph of two functions. One is going up like this and something like that. And there is another one. I drew it in red. So I will draw it in red. Okay, so we have those two functions. The black one is given by y equal minus x squared plus 4x. And the bottom one is y equal x squared minus 2x. Minus 2x. Okay, and the question is, all my questions these days are for this chapter is to find the area in between. Okay, so question one to you, what you want me to do? Are we going to take horizontal or vertical slices? And then we set up the problem. Okay, question number one. What do you want me to do first? Quickly.
Take vertical slices?
Vertical slices, absolutely, because in this problem, it's very clear. Y is given a function of x in both equations, and it's very clear. This is my top, it's the same one across the board, and this is my bottom, it's the same one. So the right thing to do is take vertical slices. Okay, that's my slice. Very good. Now, before I do the slice, I have to know which interval I need to split into pieces to cover the region. So to be able to do that, what do I need?
Intersection points.
Intersection. So I definitely need the intersection point. This is 0, so I need this intersection point so I know what to divide. Very good. So now let us look into all of them. So intersection point. We set the y's equal to each other and we solve for x. Minus 2x. Now when we solve it, we have to make it equal to 0. This x squared, I bring it to the other side, which give me 2x squared. And this would give me minus 6x. Always when we're solving, we factor. So we factor the 2x. I'll be left with x minus 3. It means intersection point, x equals 0, x equal to 3. Okay. So if I need to, the interval I need to subdivide into pieces is the interval between 0 and 3. Okay. And now we can check actually that 3 is correct. If I plug 3 here, I get 9 minus 6, which is a 3. If I plug 3 here, I get minus, am I right? If I plug 3 here, I get 9 minus 6. If I plug 3 here, I get minus 9 plus 12. Yeah, which is minus, which is 3, both sides. Sorry. Okay, so it's definitely the correct point.
All right. I have a question real quick. I just want to make something clear.
Sure.
So we put the x intersection points in the y equations, and then we should get the same thing for each.
Exactly, exactly. That's the intersection point.
Okay,
If you don't, it means something is wrong.
something's wrong.
Absolutely,
All right.
absolutely. Because it's the same point. That should be the same x and y coordinate. Anything else will not be acceptable. Okay, all right. So now we know which interval we have to divide. I took my typical rectangle and now I label it to know what I am doing. The width is the delta x. So x is my variable, because this time, whenever you divide the x-axis into pieces, that's going to be your variable across the board. X is my variable. This is my delta x. From here to here, if this point is right here, sorry, if this is my point xi, this is my top curve. So this is, I plug in xi into the equation of the top curve. That's the way we think. This is xi, and this is my bottom curve. Means the y coordinate is the value of this y at the top curve. So finally, the length is, that's the length of my rectangle, is the value at the top minus the value at the bottom. So this is minus xi squared plus 4xi minus xi squared minus 2xi. Okay, now I have the whole picture. So now I compute area of typical rectangle. Equal to the height of it, or the length of it, times the little bit of the delta x. That's the width. They have a width in here. Okay, so it's going to be minus xi squared plus 4xi. That's the top. The value at xi at the top curve minus the value at the lower curve, which is xi squared minus 2xi. So now what's the total area? The total area, this is where I am thinking about adding those. So that's the total area. And that's where I start getting what we call the Riemann sum. So in terms of integral, it's equal to the following integral. I need to divide 0,3 into pieces to cover my region. And this is equal to the top curve minus x squared plus 4x minus x squared minus 2x. Now I just simplify a little bit inside, and then I will not finish when the integral is very easy. So here I will have minus x squared plus 4x minus x squared plus 2x dx. And finally, this is equal to minus 2x squared plus 6x dx. The rest, there is not much into it. So this would give me antiderivative of x squared is x cubed plus 6. Antiderivative of x is a half x squared. You evaluate this between 0 and 3, and you get your answer. Okay. All right, shall I move on? Okay, so that's the basic problem of dealing with that. So let's look at other problems, and every time which slices is what fit the problem. And okay, let's look at number 23. 23. Right. I sketched the graph. And this is the graph they gave me. I have a parabola going like this, and I have a line. Okay. Good. And this parabola have for equation y equal, no, it's x equal y minus 2 square over 3. And this is y equal 8 minus x. Okay, so this is my picture right here. And the question is to find the area. Very good. Question number 1 is, will horizontal or vertical slices fit this problem? Which is the easiest? And I want it to justification for that.
Horizontal.
Horizontal because
Because the first part, if you go all the way to the left of the curve, then you would have both the top and bottom being the x equation.
so you said horizontal, right?
Oh, yeah, I'm saying horizontal because if you use vertical, then the top and bottom part will be the same for the first little part right there.
Mm-hmm. So if I use vertical, here, that's the top and that's the bottom.
Yes.
Here, the top is changing. It's the line. The bottom is the curve, but the top is changing. So if I use vertical, we have one issue. We have to split, because if my rectangle is here, that's the top. That's the bottom. If my rectangle is here, that's the top, and that's the bottom. So if I'm going to take those kind of slices, I'm forced to split at this stage. Now, if I take horizontal, what I need is the left curve and the right curve the same. So if I take those type of slices, okay, horizontal, watch, regardless where I take it, the left curve is this parabola, the right curve is the line. Left curve, parabola, right curve is the line. So regardless where I put my rectangle, I know exactly what's going to be my left curve. It's always the same. That's my right, and this is my left. Okay. Adding to that, another reason is easier to use horizontal is this curve, the parabola, x is given in terms of y. So if I want to use vertical, I will have to solve for y in terms of x. So this will make it also a little bit harder. And I think I forgot something. Y minus 2. Okay, so we're going to use horizontal slices. All right. Which interval I need to divide into pieces to cover my whole region by rectangle? Okay, back to you. How can I figure out which interval I need to split into pieces to cover my whole region with those horizontal rectangles? What do I need to find?
Intersection points.
We have to find the intersection point. Otherwise, I'm stuck. And then once I find them, this is the interval on the y-axis that I have to divide into pieces. It's the interval on the y-axis. Y is going to be my variable. And this here is going to be what we're going to call the delta y. Okay, so as we find the intersection point. Okay, how do we find the intersection point? So intersection point. Okay, nice. In this case, when you find the intersection point, you can either put the x's equal to each, the y's equal, or you can put the x's equal if x is given as a function of y. So it doesn't really matter which one you put. So in this problem, since the first curve, x is given as a function of y, it will be easier to put the x from the parabola curve equal to the x from the line. That will make the problem easier. So what do I mean by that? Y equal 8 minus x. Since I'm taking vertical asymptote, so I'm taking horizontal slices, it means y is going to be my variable. So I need to solve this one and express x as a function of y. So this is going to give me x equal 8 minus y. So now I have both curve, x given on a function of y. And this is going to be basically my right curve, and this is going to be my left curve. So to find the intersection, instead of setting the y's equal, I'm setting the x's equal. It means I'm going to set y minus 2 squared over 3. So I'm going to find the value of y so that if I plug it here or here, I get the same answer. whether here or here, equal to 8 minus y. Are you with me? So now I'm going to find which y has the property whether I plug it for x in this curve or for f in this curve, I get the same value. So I'm going to set the y's, which is easier in this particular problem. Okay, are you with me? All right, now let's do that. How I'm going to solve for this? Okay, nobody likes the 3. I don't, you don't. You're going to multiply across by 3. This is equal to 24 minus 3y. I need to solve. To solve, I need to expand this term. Y squared minus 4y plus 4 equal 24 minus 3y. Since that's a quadratic, I have to rewrite it to make sure there is 0 alone in one side. I factor the other side. So to do that, I'm going to have y squared minus 4 minus plus 3. It means minus y plus 4 minus 24 minus 20. And now I factor. I think we can factor it because 20, so this is going to give me equal. So 5 and 4, it's a minus, so it's going to give me that, and y minus 5. I usually check back. It's y squared minus 5y plus 4y give me minus y minus 20. So y equal minus 4 and y equal to 5. Now I go back and I check. Am I really doing this thing correctly? So minus 4 and 5, it means that this point here should be sorry. Remember, minus 4 is the y component. And this point here should be 5. 5 is the y component. But now I'm going to plug the y into the x, and that should have the same x value. If I plug minus 4 here, I get minus 8 minus 4. That's give me a 12. If I plug minus 4 here, I will have minus 4 minus 2. That's a minus 6 squared, 36. And I will have 36 divided by 3, honest to goodness, 12. So this point is correct. Okay, so this time I'm finding the y, I'm checking for the x. Now for 5, 5 minus 2, that's 3 squared, 9 over 3, that's a 3. And 8 minus 5, that's a 3. So my points are correct point, and those are intersection point. Okay, so now as I go back, so we finished the intersection. So now the interval I need to divide into pieces is, this is a minus 4 here and 5. This is the interval I need to cut into pieces to cover my whole region. And the rest now becoming a little bit simple. I don't care where you took your rectangle. Suppose this is my typical, I draw my typical rectangle, a little bit clearer, and it doesn't really matter where you take it. The same right and the same left. So this is my yi. And watch the little rectangle, how it works. It goes from the left curve to the right curve. That's the length. And this here is the width. That's the delta y. That's my delta y. Okay, so what is the length of my rectangle? It means from here to here, how much do I have? If this is yi, how much do I have from here to here? So that's my rectangle right here. So the length, the typical rectangle. The length equal the right value, it means this one here, minus the left value. Now the right value is 8 minus yi. Means from here to here, that's 8 minus yi. Whatever this number here is, from this point, this horizontal distance is 8 minus yi. I'm going to take away from it this horizontal distance. So that's, which is, if this is yi, from here to here, I have that much. I have yi minus 2 square the whole thing divided by 3. Now the width is the delta I. That's the width. So area of a typical triangle is the length times the width. That's really where the Riemann sum will come from. 8 minus yi, and this is to always remind you that's the right curve minus yi minus 2 squared over 3. And that's the left curve. Okay? So finally, what's the total area? The total area is, when I'm thinking total area, what going on in my mind is I am covering and adding. That's really what I am doing at this stage. And doing this, adding those little area will give me the Riemann sum I am after. And so on and so forth. That's really where the Riemann sum is coming from. I'm adding the sum of those little areas. So now the total area is integral. What's my variable, x or y? Because this is going to confuse a lot of students. What's my variable? Back to you.
Y.
Y.
Why? Which interval I divided into pieces? Is it the interval on the x or the y-axis? The y-axis.
Y-axis.
Yes, the delta it's a delta y, not a delta x. Y is my variable. That's what I am changing in this problem. I'm taking the value between here and here. That's the y value, and so on and so forth. So this is going to be the integral from. The lower is minus 4. These are the limit on the y. I'm totally ignoring x. X is not my variable here. And this is the dy. That's what it goes, the dy. And then the inside is 8 minus y over 3 dy. Okay, now how do we integrate this? I will get you started and you will finish. 8 minus y, that's very easy. Minus, to be able to integrate this quantity, one way to do it is expand it. So when I expand it, I will get y squared minus 4y plus y over 3, the whole thing dy. Okay, so this is going to give me the following. I can do it, I can split it, I guess, because if I split it, it will be easier in this problem. Eight minus y dy minus 1/3 integral from minus 4 to 5 of y squared minus 4y plus 4 dy. Okay, do you understand what I did? Anybody had any questions? So I split, I took this by itself. And for this piece, I took minus 1/3 out, and I have a simple integral inside. And the rest, there is not much to do about it. Okay, the rest is easy. So that's 8y minus 1/2 y squared between minus 4 and 5 minus 1/3 y cubed minus 4/2 y squared plus 4y evaluated between minus 4 and 5. Okay, and the rest you will finish it. I do not finish the rest. Okay. Questions? Please go over that and make sure you understand it. I know that that's the problem you have on MATLAB, but that's the idea. The idea is that you have to understand. Questions?
I have one real quick.
Quick.
So for the final part, would you once you find both the antiderivatives, you would put them together, right? With the subtraction symbol in the middle, then do the 5 and the -4 then, or do them separately?
Where here? It doesn't
Yeah.
matter. It doesn't matter.
Okay.
It doesn't
Okay.
matter. Yeah, because it's the same limit. It doesn't
All right.
matter.
Thank you.
Okay. Any other questions? Okay. All right. So So I think we still have one to look at, and then we can proceed. So I'm just looking at the problem. So let's look at number 63. Actually, I look at number 49, and then I look at number 63. And sometimes I will just ask you questions. So number 49 is the following. The region in the first quadrant bounded by y equal x to the power 2/3 and y equal 4. Okay, very good. First we graph. This time there is no graph, we have to do it. Y equal x to the power 2/3. So if you guys can, you can pick up your calculator, or, you know, if my memory is right, this is gonna look something like that. And this is 0. This is x, y equal x to the power 2/3. And they tell me in the first quadrant, so they don't care about this piece down here. And y equal 4. If this is 4, y equal to 4. Okay, so it should be something like that. And the curve goes this way and the line keep going. So that's the line and that's the curve. So it's the region bounded by the curve, and it's in the first quadrant. So that's what I am interested in. Okay, so it's not really a hard problem in this scenario. Vertical or horizontal slices? Let me ask one student. Dylan, which type of slices would you take? Are you with me, Dylan? Okay. Edgar Favela, what you'd like to take?
Oh, what was that?
Yeah, vertical or horizontal slices?
I'm sorry, I can't hear that one.
Vertical or horizontal slices?
Horizontal?
Why horizontal?
Because it was y is equal to 4.
Yeah, so this is y equal to 4. And so that's y equal to 4, basically, that's my curve. And this is y equal x to the power 2/3. So why did you take horizontal?
Because you could put it in terms of x.
Which, this one?
Yeah.
You can do that. Is it necessary? Is it necessary?
I mean,
What's the top curve in this problem?
y is equal to 4.
Okay, what's the bottom curve? Is it the same across the board? Does it change? Is it changing? So if I take my typical rectangle, right there, okay, a vertical one.
No.
Is the top curve changing?
No.
Is the bottom curve changing?
Yeah.
How? How is it changing?
Because it's approaching y is equal to 4.
So, but it's still, there is a little bit here. I mean, it's approaching, but is it changing? Is it the same curve, or all of a sudden another curve?
No, this is the same curve.
The same curve. So we don't really need, we can, but we don't have to. So this is my top curve. It's the same across, and this is my bottom curve. So if I take my vertical slice, finding the length, which I'm going to ask you guys to tell me what it is, that's my top and that's my bottom. So I don't really have to split. And y is given very easily in terms of x. So there is no need to take the horizontal. We can, but there is really not the necessary need to do that. I know my top and I know my bottom. What do we need to find though? First, I need to
Intersection
find
points.
the intersection points. So I know which interval I need to divide. So let us find the intersection point. So I need to set the y from the first curve, the top y, equal to the y from the second curve, and solve for x. All right. Now, I have to the power 2/3 to be able to solve. One way is raise both of them to the power 3/2. If I both of them to the power 3/2, this will give me an x. And 4 to the power 2/3, it means 64, right? Am I correct?
Isn't it 8?
I think it's 8.
Yeah,
Eight.
And
8.
8 as well.
Ah, it's 2 to the power 3, sorry. My mind went blank. X equal to 8. So this is my x equal to 8. And if I plug in 8 here, 8 to the power 2/3, that's 4. I am on the right. So this is my 8. Okay. So now I find the intersection point. This is the delta x. And now I need the length. If this is xi, what's the length here? So length of typical rectangle is equal to width is the delta x this time, area equal. Okay, so what's the length of my typical rectangle? I'll ask another student, please. Eric Shelton. You guys have to stay with me. What's the length? Means how much do I have from here to here?
Wouldn't it be 4 minus x to the power of 2/3?
Absolutely correct. That's the length. Okay, so this is my 4. Right here, this is a point on this curve. It means from here to here, the output is xi to the power 2/3. And from the top curve to the bottom curve, I have 4 minus the value here. Now finally, so the area is the product. That's the length times the width, and the total area is the integral from 0 to 8 of 4 minus x to the power 2/3. The rest is very simple. Antiderivative of this is x, 4x. Antiderivative is 1 over 2/3 plus 1, which is going to give me 5/3, x to the power 5/3, between 0 and 8. You finish the problem. It's simple at this stage. Okay. All right. So I guess I did most of the homework for you. That's okay. So now I look at number 69, and hopefully this section should be crystal clear so I can move on. So 63 is the following. I have a line, I have another line, and I have a curve. Very nice. So my curve is y equal 9 minus x squared. This is, I should do like the book, draw this in red. So this is in red. That's nicer. And this is y equal 8x. And the bottom one, this line is y equal 5/2, 5 over 2x. Okay. And okay. And the question is, we need to find the area in between. So this area. All right. Ideas.
Either way, we're going to have to do it in 2 different sections.
We have to do a different section. And how, what am I supposed to do to know where to divide? Now first, you want to take horizontal or vertical?
I mean, we can do vertical because
We can do
I think
vertical.
either one works.
Yeah, we can do either one in this case. So let us think about vertical first. Okay, vertical slices. Okay, what do you need to find to be able to actually even, what's the top curve? Is it changing or not changing?
It's changing.
Yeah, where is it changing? At the beginning is the red, right?
At the beginning, it's
was
red. Then when you get to that point, the intersection point, then it changes to
it changes.
9 minus x squared.
Exactly. Is the bottom changing?
No.
No, very good. Now, if you take horizontal, you don't have to write. Let us think about it. Horizontal. Is the left and right changing? Erika, what do you think?
Yeah.
Yeah, is the left changing? So, can you elaborate?
It starts with 9 minus x squared on the left, and then the 5/2 x.
Well, it's the left curve, sorry, the right curve is this, then it's gonna change at this stage, and the left curve is not changing. The left curve is always the red, the right curve is changing. So whether you take vertical or horizontal, it doesn't matter in this problem, you have to split. You have to split the problem. So since you guys picked vertical, I'm gonna stick with that and proceed. So if I take my rectangle here, that's the top, that's the bottom. If I took my rectangle here, that's the top, that's the bottom. So I need to split right there. That's when the change is occurring. Okay, very good. So I need to find the intersection point. So I need to find this point. So I need where the splitting occur. I need to find this point to know where the splitting occur. And then I have 2 different areas. So intersection point. The first one, I need to set 8x equal 9 minus x squared for the point A. Let us say, let me call it A. Okay, and then how much do we get here? Anybody got the answer? This is 0. So I will have x squared plus 8x minus 9. And of course, this is gonna give me a 9. So that should be a 9 and a 1. And an x and an x should be a plus here and a minus here. Okay, so this is gonna give me x equal minus 9, x equal to 1. Now,
wouldn't it be 8 instead of 9?
well, here,
Yeah, wouldn't it be x minus 8 and x minus 1?
it can't
Oh,
be.
never mind.
No, no way, because I have a 9 here. So now let me, so I'm finding x, minus 9 doesn't apply because my value is positive. So the 1 is the one that applies. And let's see if it makes sense. If I plug it here, I get, sorry. If I plug it here, I get 8. If I plug it here, I get 8. So I am safe. Okay, so that's my first intersection point. Now I need my other intersection point. I'm going to call it B. So I know what we're talking about here. For B, I need 9 minus x squared equal 5 over 2x. I multiply by 2 because I don't want to be working with 2. I will get 18 minus 2x squared equal 5x. I have to rewrite it. So one side will be totally 0, so I can factor. So I'm going to get 2x squared. I bring it here, plus 5x minus 18. Okay, and then you can either use the quadratic or you can factor. Did anybody try to factor this out? Anybody try to factor it out? Okay, I will give it my best shot. That's 2x squared. It should be 2x and x. Minus 18. We can take 1 and 9. 2 and 9. We can take 3 and 6. So I will try those. And then I get minus 18, 5x. So minus. And then I check out. So I get x equal 2, x equal minus 9/2. Now I multiply 2x squared, give me this, minus 4x plus 9x, that's plus 5x, minus 18, I'm safe. This goes, because my x is positive, this one will have to stay. So x equal to 2. Now let me check. If I plug x equal to in this equation, I get a 5. If I plug it here, I get a 5. I am absolutely fine. So these are my points. Okay. And now the area. What's the area? I'm going to just set up the area this time without doing everything. We're just going to set it up. What's going to be the area? Equal to. So the division will have to happen right here, which is 1. So what's happening now? If x is between 0 and 1, the top curve is, the bottom curve is. If x is between 1 and right here, this is a 5. What's the top and what's the bottom? All right, now I'm gonna pick one student and this one student have to answer. And if they don't, I start taking points off. Kiana. Kiana, are you with me? I'm sure you are.
Yeah.
Yeah. Answer my questions.
The top is 8x and the bottom is 5/2 x.
Very good.
And then the top for that one is 9 minus x squared. And the bottom is 5/2 x.
Absolutely correct. Stay with me, Kiana. I want the area. So for the area, we're going to split into 2 pieces. That's, I call it R, and I call it S. So the area is area of R plus the area of S. Okay, Kiana? Can you give me the formula for the area of R?
8
First,
x.
what's the lower limit? What's the upper limit?
Upper limit is 1, lower limit is 0.
Absolutely. And basically, I'm putting here the area of my those rectangles. That's what I'm adding. So what do you want me to put inside the integral?
8x minus 5/2 x.
That's area of R. Okay, what's the area of S?
Upper limit is 2, lower limit is 1.
You're absolutely right, and I am absolutely wrong. Thank you. So from 1 to 2, actually, I'm going to put it down here. And fill in the details.
9 minus x squared minus 5/2 x.
Absolutely correct. The rest is up to you guys to do it. I will not finish the problem. Okay, that's really the setup. Very good. Now the challenging part. If I take this picture, okay, and I'm going to ask you to do it. Since I have 5 minutes, I cannot start a new section today. I want to do the same problem by taking horizontal slices. Okay, and expect that tomorrow. Okay, so I'm going to take horizontal slices. What would be the situation, just out of practice for this whole picture. So I'm going to draw the picture again, and I'm going to do it taking horizontal slices. So this is my line. No, this should be in black or in purple. So that's my parabola here. And this is my other line. And I will put what's given to me. Y equal 8x. And I'm going to put y equal 5/2 x. And this is y equal 9 minus x squared. The intersection points were 1, 8. And the intersection point were 2, 5. Okay, and now practice problem. Let us say I want you to do it. We've done it now. Let us say I want you to do it using horizontal slices. Okay, and my question is how we're gonna split the problem and what's gonna be the setup.
Would it be useful to, in this problem, to do horizontal slices instead of treating the equations as they normally would be with y equal to something, blah, 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 like times x, to treat x as y and y as x?
Wait, you prefer this problem to be vertical slices?
No, that's not what I was trying to say. I was trying to say if we're trying to look at it horizontally, then we could treat x as y and y as x.
No.
And it'd be okay. I guess I'm right.
Horizontal slices, we have to do it the way. So we have to take those rectangle and ask ourselves.
Do you understand what I was trying to say, though?
Yeah. No.
Because if you assume that the y-axis is the x-axis,
yeah,
then it's essentially
it's
the
a
same.
it's very confusing.
Okay.
You will be lost. I would rather
Okay.
do it this way. Okay.
Okay, that's fine.
Yeah, that's fine. All right, horizontal slices. How do you want to split it?
Don't we make a horizontal line between the 2, 5,
Exactly.
and
Where
1, 8?
where exactly? Where exactly? Where do you want me to do it? For y equal to what?
Y equals 5.
Right. So that's where the cutoff is going to be. So this is my 12. This is my 0, and the cutoff will be. So I need this, because that's where the change is happening for left and right, plus that. That's what's happening for left and right. Step number 2. If I want to do horizontal slices, what do I need for this equation?
Don't you have to turn them all into x equals
Right.
like
For each one of
that?
them, I have to find x as a function of y. So those are simple ones. The first one, x as a function of y, x is 2/5. This one, x is a function of y. X squared is 9 minus y, square root of 9 minus y. Every one of them. So this is as a practice problem. We've done this, but this is so we fully understand vertical, horizontal. And now if I need horizontal slices, I'm going to do like before. Okay. If my slice is here, it means if my y is between 0 and 5, what is the right curve? What is the left curve? My y between 5 and 12, what is my right? What is my left? And finally, what's my area? Okay. All right, so I will pick one of you and I pick Eric. Let me pick Gavin. Gavin, can you help me?
Yeah. So for your right, it's gonna be 2/5 y, and then the left is gonna be 1/8 y,
Yeah, he's right, of course. Yeah.
and then the next one, the other right, is gonna be the square root of 9 minus y, and then the left is 1/8 y.
8 1. And now the
So
area.
the
Yeah.
area, the limits are from 0 to 5.
That's the first one, because to cover this region, I have to divide the interval from 0 to 5. And okay, help me out.
It's 2/5 y minus 1/8 y
Right, it's the right value.
times
What's
the
here
inverse.
minus what's here. And this one,
It's from 5 to 8. And it's the square root of 9 minus y.
because you're computing the length from here to here, minus the length from here to here. That's really how I visualize it all the time. What did you say? Square root of 9 minus y?
Minus 1/8 y dy.
Okay, so that's the problem done in both ways. We picked vertical because it made sense because they gave me for all of them y as a function of x. And as a practice, I made you do the other way around, just so to learn exactly how we deal horizontal slices. Okay. All right, that's it for today. Tomorrow, for those who did not finish their homework, we basically did them. You have to finish them. And you're gonna start a whole new section next time, okay? All right, any other questions before we proceed?
I have a quick question.
Yes.
You mentioned My Lab. How do you access that? Because I looked, I went through Brightspace and clicked on the content tab, went to assignments, and I clicked on it, but it just showed the numbers that you had to do.
Oh no, you go to My Lab. You don't go through Brightspace.
Oh, so you have to go through a separate actual website.
Right. You go through My Lab. One of your classmates. Okay, one of your classmates can explain it to you. Can anybody tell him how to do it?
Yeah, it's pearson.com. That's the website. And so you make an account, and then I'm pretty sure on her announcements it has like the course code. And if I'm
Yeah.
wrong about that, somebody can say. But yeah, it's a completely different. It's not Brightspace at all. The information for it is on Brightspace.
Oh, okay, thanks.
Did you follow what he said? On Brightspace,
Yes.
I gave you all the info you need. Okay. Freddie, can you stay with me? Who's very comfortable using my math lab?
Oh, I like it.
Okay, I want somebody to stay with me because one of your classmates need help. Okay, can you stay with me a little bit? Or you have a class? Who's talking to me?
I could stay a little bit.
Okay, so one of your classmates, Freddie, also stay, and you stay. He needs some help with my math lab. Anybody need help with my math lab? Okay, so it's not through Brightspace. Follow the registration I gave you verbatim, and you should be all right. Okay, so the class ended, and the two